This video is going to be focused on the reasons for the seasons. Specifically, we're going to look at how Earth's tilt and solar intensity influences why we have different seasons. So the first thing to consider is that the Earth is tilted at about 23.5 degrees. So during our winter in the northern hemisphere, the Earth is tilted away, so the sunlight we're receiving is more spread out and is not as intense as it is during the summer. So let's look at this so we can get a better visual. So during the summer, here we have the rays of the sun shining down, and it's more concentrated. It's more intense because it's hitting a smaller area. However, during our winter, we have the same amount of energy coming in, but now because it's coming in at a different angle, it's being spread out over a larger area. So it's the same amount of energy hitting a larger area, which means that it's not going to be as strong. And you can think of this the same way as a flashlight. If you were to hold a flashlight directly overhead of a surface, it's going to concentrate that light and energy into a smaller area, just like we see here. Now, if you were to tilt that flashlight, it's going to spread the light over a larger area, just like in this image right here, but it's the same amount of energy. So the flashlight energy isn't getting any stronger, it's just spreading that light over a larger area, and that's what's happening during our winter time. Here's another image that shows that. So during the summer, the sun is higher overhead, which makes the light more direct, and it's going to focus it in a more intense way. During the winter, our winter, the sun is lower in the sky, and the angle of sunlight is much lower. So it's going to spread that light over a larger area, therefore it's not going to be as intense. So let's go back to our interactive here. So we have our observer set at about 44 degrees north. That's about the latitude that Vermont's at. And if you look at this image, you can see this is the sunlight. These arrows represent incoming sunlight, and it's a pretty shallow angle. So the sun's altitude's only at about 22 degrees, and this is during the winter. So the sun's relatively low in the sky for much of the time. If you think of a winter day, usually it feels like it's either kind of morning or afternoon because the sun never really gets that high. During the summer, the sun's much higher in the sky and we have longer days. If we click on sunbeam spread, here we can see, as I was mentioning before with the flashlight analogy, that the sunlight is spread out over a large area. It's not very concentrated, and that's because of the angle that the Earth is at. So here we are, and we're up kind of where I'm pointing the cursor. So we're facing away from the sun. We're tilted away from the sun, so the sunlight is not very direct. So what I'm going to do is I'm going to start this animation, and we're going to see how that changes throughout the year. So here we have our sunlight, and before it was kind of coming down from below and it was spreading out. But as we go into late winter and spring, we can see that it's now being more concentrated. So because the light, if we go to sunlight angle, it's becoming more direct, it's overhead because the sun's altitude is increasing. Now that sun, just like a flashlight, is becoming more and more concentrated. So if we go back to our sunbeam, now it's over same amount of energy, but over a smaller area. And I'm going to stop it here on the summer solstice, or about around there. And now that sunlight is focused on a very small area within one of these little boxes. As before, it was spread out over about 3 boxes. So if we go to sunlight angle, the angle of the sun is nearly overhead, so it's very direct. And again, this is related to because we're tilted during the summer. Here's the Earth during the summer. We're tilted more towards the sun, so we're receiving more direct sunlight. Therefore, the sunlight is more concentrated, more intense. If we keep on going, we can see that as we progress into fall, the sunlight is becoming less intense right here because it's not as direct. If I go back to sunlight angle, sun's altitude is decreasing as we go towards wintertime, and because the angle is decreasing, then the sunlight, if we look back here, is not as intense. It's being spread out over a larger area. So during the wintertime, we have shorter days, and the sunlight is spread out over a larger area, which means it's not as intense. During the summer, if I move us back to the summer, The sunlight is going to be more intense, and we also have longer days. And the reason it's more intense is because the sunlight is more direct, because the sun's further overhead. There are other aspects that play into why we have seasons, but solar intensity is one of those reasons. And again, it's related to the tilt of the Earth, and that causes the sunlight to become more intense due to how direct it is. Something to consider as we wrap this up is that during the wintertime, we're actually closer to the sun than we are during the summer.